welcome to Chemical Reactions Part 2. Today we're going to talk about the factors affecting the speed or the rate of chemical reactions. Now let us consider the first factor, the surface area. And when we say the surface area, we mean the surface area for the reaction. Let us consider if I have a large chunk and if I have smaller chunk. I have, for example, calcium carbonate as the chunk and the acid, which is the red circles. For the green circles to react with the red circles, the ones outside must react first. But if I take the large piece and I crush it into powder, now more particles are exposed. The chances of the red circles colliding with the green circles increases. So this is why we say larger surface area. It's larger surface area exposed for the reaction. And if I have that, then I have higher chances of successful collisions. Remember we said for a chemical reaction to happen, particles must collide and collide successfully. This will have higher chances when I have larger surface area exposed for the collisions, which is why we say large pieces have small surface area. Powder has the largest surface area, meaning exposed for the reaction. So we say, in summary, increasing surface area increases the rate of the reaction because more particles are exposed, so more successful collisions per second. Now let us talk about concentration. The term concentration means how many particles dissolved per unit volume. Consider these two containers. In one of them, I have two particles of blue, and the green is supposed to collide with the blue for a reaction to take place. Now consider the second one. The number of the blue increased dramatically, and we say that increasing concentration. So in which container do you think the chances of successful collisions is higher? It goes without saying. When it is more crowded, or in chemistry terms, more concentrated. So we say the rate of the chemical reaction increases by increasing concentrations of the reactants. Why? Because more particles dissolved per unit volume, and therefore more successful collisions per second. The pressure for gases is the same as concentration in solution. Essentially, you have larger number of particles per unit volume as well. I understand the number of the particles did not change, but when you increased the pressure, you decreased the volume where the particles exist. The spaces between the particles decreased, bringing the particles closer together. This is why we say that when you increase pressure, it is exactly like increasing concentration. More particles per unit volume, so more collisions and more successful collisions per second, or higher rate of reaction. If you remember activation energy, we say that activation energy is energy needed for the reaction to proceed, or minimum amount of energy required by colliding particles for a reaction to take place. The presence of high temperature, increasing temperature, does a very, very unique thing. It makes the particles gain energy, and as they gain energy, they start moving faster, increasing the chances of successful collisions per second. But also, more particles will have energy equal to or more than activation energy. Remember, this is the minimum amount of energy needed, but not all particles have it. When you increase energy, when you heat the particles, they gain energy and they become able to go up the hill. They become able to react because they will gain activation energy. So in summary, we say that increasing temperature increases the rate of the reaction because particles gain energy and move faster, causing there to be more successful collision per second, and a very important point, more particles will have energy equal to or more than activation energy. A catalyst is also related to activation energy, except this time the catalyst controls the activation energy and it has nothing to do with the particles. Meaning, the catalyst lowers the activation energy, makes it easier for the particles to react, or increase the fraction of successful collisions. This happens because the catalyst has active sites that the reactants bind to, and they leave again after they react. You note that the catalyst remains unchanged by the end of the reaction. And this is how we define a catalyst, a substance that increases the rate of reaction by lowering activation energy, and it remains unchanged in the end of the reaction. An enzyme is simply a biological catalyst. Mind you, even more effective than mineral catalyst, but it works exactly the same. Active sites, the substrate binds to the enzyme, and then it leaves us the product, leaving the enzyme as it originally started. Last but not least, the effect of light. Some reactions are affected by light. For example, the reaction of hydrogen and chlorine. In the dark, no reaction. In the light, they react. And this is why we call them photochemical reactions. They are reactions which rate is affected by light. Most, of course, famous one is photosynthesis, where it needs light energy. The chlorophyll acts as the catalyst, and it takes place in the green leaves, where the carbon dioxide and the water bond to make glucose and oxygen. And by that, we finish the factors affecting the rate. Have a lovely day, everyone.